Today we are going to discuss chapter 11, P-block elements. A lot of questions are here, so we can directly go to the questions. The first one. Name the colorless toxic gas that is produced when BF3 is heated with the sodium hydride NH at 450 Kelvin. Draw its structure. If it is BF3 and sodium hydride, it is very clear the compound is B2H6 diborane. And its structure is very important because of 3 center 2 electron bonds. It is the structure of B2H6. You have to draw it 3 or 4 times and study it well. This is the structure of B2H6. You can see 4 terminal BH bonds. These are ordinary bonds. And these two bonds are bridge bonds. BHB hydrogen bridge bond. And these two bonds are known as 3 center, 1, 2, 3. 3 center, 2 electron bond. Only 2 electrons are present here. But this bond is 2 center, 2 electron bond. 2 center, 2 electron bond. Okay, we can see the next one. Write short note on fullerenes and silicates. Fullerene, what is fullerene? It is an allotrope of carbon. The important fullerene is C60. C60. It is football-like or soccer ball-like structure. Hexagons and pentagons are present. Carbon hexagons and carbon pentagons are present. 26 membered rings and 12 5-membered rings are present in the compound. So such things you can write. Now what are silicates? Silicates, they have basic structural unit SiO4 4 minus tetrahedra. Here you can see SiO4 4 minus tetrahedra. You have to study it. You will get this question as 1 mark question. So SiO4 4 minus tetrahedra silicate, you write it 5 or 6 times and study it well. Okay, they exist in different forms like chain, ring, sheet, or 3-dimensional structure. Example, zeolite, mica, feldspar, asbestos, etc. Draw the structure of diborane, repetition of question. Write a note on the nature of bonds present in it. Already we discussed. Structure, I told you, you have to draw it 2 or 3 times and study it well. And what are the nature of the bonds? Terminal BH bonds are 2 center 2 electron bond, but bridge bonds are 3 center 2 electron bonds. That is the important. What are silicons? Silicons are inorganic polymers. Silicons are inorganic polymers with molecular formula R2SiO n times. R2SiO n times. Here you can see R2SiO n times, or R2SiO as the repeating unit. Write the chemical equation showing the steps involved in the manufacture of silicon. Here you have to remember methyl chloride or alkyl chloride, when treated with the silicon, you will get different types of compounds. Out of these different types of compounds, you select dialkyl silicon chloride or dimethyl silicon chloride. Dialkyl, it is not compulsory that you have to use methyl chloride. Any alkyl chloroalkane can be used. So dialkyl silicon chloride will form. That on hydrolysis gives a dialkyl silicon hydroxide, which will undergo polymerization to form silicons. How can this inorganic polymer, that is important, you study it well. How can the chain length of silicons be controlled during their synthesis? It is asked only once, but very important. You please note it. If you can write it, you will get the complete mark. Very simple thing. By the addition of CH3 thrice SiCl, if you can write it, that will help you to score complete mark. By the addition of CH3 thrice SiCl, that is enough. Okay, now we can go to the next question. Write the formula of the basic structural units of silicates. I told you there is a chance to get this question for 1 mark. SiO for 4 minus. Study it well. What are zeolites? Given two uses of zeolites. Now you are familiar with the zeolites. In the catalysis we have studied. It is a shape selective catalyst in the second year topic, and the first year in the purification of water for the removal of hardness. Zeolite under the name permutate. We are using it as a permutate. So what are zeolites? Zeolites are aluminosilicates. They are widely used as catalysts in petrochemical industries and for removing hardness of water. Sketch the structure of graphite and diamond. What are the importance of structure and physical properties of these allotropes? Graphite, we know one carbon is bonded to three other carbon atoms. One carbon atom is in sp2 hybridization. So one electron is free, and a graphite has layer structure. So one layer can slide over the other, therefore it can act as a lubricant, and it is a conductor of electricity. But diamond, one carbon is bonded to four other carbon atoms, and it has sp3 hybridization. And since it is sp3 hybridization, the substance is hard and there is no free electron. It is a structure. If you can draw the structure, that will help you to get the mark. However, you have to note the structure of graphite and diamond. Okay, next question. Allotrope of carbon with the highest thermodynamic stability is graphite. You have to note it. It is not diamond. Diamond is hard, but it is not fullerene, but it is graphite. The allotrope of carbon with the highest thermodynamic stability, graphite. It is asked 4 or 5 times in the previous question papers. To study and remember it well. Draw the structure of orthoboric acid. Why it is not a protonic acid? Orthoboric acid has a hexagonal structure, but no need to draw it completely, just to show how the OH groups are arranged around boron. 3 OH groups, just to show 3 OH groups around boron. Why it is not a protonic acid? Boron is electron deficient, you know. Only 3 bonds, so total 6 electrons are present in the outermost shell of boron. So it requires 2 more electrons. So it acts as a Lewis acid, and it will take this electron pair from OH minus in water. Thus it will form BOH 4 times negative and H3O plus. So we cannot call it as protonic acid, but it is a Lewis acid. Explain any one method of preparation and structure of diborane. Again question, already we observed one method, NAF and LIH. Sorry, not NAF, BF3 and LIH. Similarly, BF3 and lithium aluminum hydride reduction. The reduction of boron trifluoride with the suitable reducing agent, LiAlH4. It is one of the method, and explain the structure. Structure we explained several times. Diborane and repeated questions. Diborane is an electron deficient compound. Explain the structure of diborane. What is water gas? CO plus H2. Already we discussed. CO plus H2 is water gas. Producer gas, CO plus N2 is producer gas. Inorganic benzene is B3N3H6. Inorganic benzene. That is B3N3H6. It is the structure of diborane. Okay, now question number 12. Borax is an important compound. Yeah, the solution of borax is alkaline. Give reason. Borax Na2B4O7. When it is dissolved in water or when it is treated with water, what happens? NaOH plus boric acid. H3BO3 will form. Boric acid is a weak acid. NaOH is a strong base. Therefore, the resulting solution is basic in nature. Given it 2 uses of borax. Borax is it has an antiseptic property. Then it can be used for borax bead test. Now, for the preparation of borosilicate glasses. Borosilicate glasses are heat resistant glasses. Glass wool, similarly glass wool, fiberglass. So you write only one use. Diamond has covalent bonding, yet it has high melting point. Due reason, one carbon is bonded to 4 other carbon atoms, and the hybridization is sp3 hybridization. Therefore, it is very hard. That is the reason. CCl4 does not undergo hydrolysis, but SiCl4 undergo hydrolysis. Why? The answer is, in carbon, there is no vacant d orbital, but in silicon, there is vacant d orbital. That is the answer. Since there is vacant d orbital in silicon, it can accept electron pair from water molecule, thus undergo hydrolysis. Carbon has no vacant d orbital or any other vacant orbital, so it cannot accept electron pair from water molecule, therefore not undergoing hydrolysis. So what is the answer? Actually, what is the answer? Carbon has no vacant d orbital, but silicon has vacant d orbital. That is the answer. Differentiate between silicates and silicons. Already we discussed. Silicates with the basic structural unit SiO4 4 minus. Silicons are inorganic polymers with the formula R2SiO times. Here the answers are given. Carbon has many allotropes. Write the name of any 2 allotropic forms of carbon. You can see the allotropes of carbon that is repeatedly asking. So take care to study it well. Which are the allotropic forms? Graphite and diamond. Briefly explain. Fullerene also there. Briefly explain the structure of any one of the above mentioned allotrope. Already we explained structure of graphite and diamond. CCl4 does not undergo hydrolysis. Give this reason: absence of d orbitals. When BF3 is treated with the LiH at 430 Kelvin, 450 Kelvin, a hydride of boron is formed. Which is it? Diborane. Hydride of boron, diborane. We are not studying about any other hydride of boron. So if it is asked the hydride of boron, surely you can write diborane, B2H6. Identify the hydride of boron formed in the above reaction, B2H6. Briefly explain the structure of the above mentioned hydride. Now we are reading it for 5 or 6 times, isn't it? That is the importance of structure of diborane. Study it well. Boron compounds behave as Lewis acids. Why? Boron, it has only 6 electrons in the outermost orbital, so it is electron division. So always it has a tendency to accept electron pair. If it is accepting tendency to accept electron pair, it will act as Lewis acid. Orthoboric acid is an important compound of boron. Prepare a short note on orthoboric acid highlighting the following aspect. Method of preparation. Already we mentioned one method, borax, when it is dissolved in water, orthoboric acid will be formed, or borax when treated with acids like HCl, orthoboric acid will be formed. It is acidic in nature. Already we discussed it. Orthoboric acid can accept a pair of electrons, so it acts as Lewis acid. Action of heat. When it is heated, boric oxide B2O3 will form finally, and its structure, you may remember, center boron and the 3 OH bonds. 3 OH groups are bonded to boron. You may remember that structure. Here you can see the answers. OH 4 times plus H3O plus. You have to study this equation. It is asking several times why it is a monobasic acid, why it is not a protic acid, how it acts as an acid. Such several questions are asking from this part. So if you have this equation, that will help you to get mark. Okay. Thermodynamically most stable allotrope of carbon is graphite. Carbon is the first member of group 14 in the periodic table. Why does carbon differ from the rest of the members of its group? Already we discussed 4 reasons. Which are the 4 reasons? First one, small size, high electronegativity, high ionization enthalpy, absence of d orbitals. Write any 2 anomalous properties of carbon: stable tetravalency, and it cannot expand its valency beyond 4. And the second one, catenation. self-linking property of carbon. Third one, p-pi bond formation. Such a number of things you can write as the anomalous properties of carbon. The answers are here. If you want any clarity, read the answers. Okay, now question number 18. Give reasons for the following. CO2 is a gas while SiO2 is a solid. Another important question is repeatedly asking. CO2 forms separate molecules or discrete molecules. C double bond, or due to the formation of double bond, CO2 is a single molecule. So such a single molecules are existing together, therefore weak force of attraction between the molecules. But SiO2 is a three-dimensional network solid, not separate molecules. They are joined. Therefore, Si2 is a solid, CO2 is a gas. CCl4 cannot be hydrolyzed, but SiCl4 can be hydrolyzed. Already mentioned. CCl4 in absence of d orbital, SiCl4 d orbitals are present. Borax bead test can be used to identify metaboranes in the laboratory because metaborites are colored. Graphite is used as a lubricant in machines. In graphite, carbon atoms are sp2 hybridized. So one carbon atom is bonded to three other carbon atoms. Therefore, it forms layer-like structure. One layer can slide over the other. Therefore, it can act as a lubricant. You can see the answers here and study it well. What is dry ice? Solid carbon dioxide is dry ice. Why does BF3 behave as a Lewis acid? It is asking for 3 or 4 times. You know, boron has only 6 electrons in the outermost orbital. It is electron deficient. So it requires 2 more electrons. Therefore, it acts as Lewis acid. Carbon forms millions of compounds due to its self-linking property to form long chains and rings. Name the above property of carbon. Catenation. In the last question we mentioned it. Catenation. Give the reason for the above property of carbon. It's a stable tetravalency and the high bond strength of carbon-carbon bond. That is the reason for that. Okay, boric acid, H3BO3 is considered as a weak acid. Why? Because it is a Lewis acid. It is not releasing H plus ions. Actually, it is accepting an electron from OH minus ion in the H2O. That is the reason. Carbon monoxide is highly poisonous. Why? It combines with the hemoglobin to form carboxyhemoglobin. It is very important. Carboxyhemoglobin. If in the answer this term, you will get the mark. Carboxyhemoglobin. What are zeolites? What is its use? Repeated question. Sodium, aluminum, silicates. Aluminosilicates. Sodium or potassium or any other metal can be attached. It can act as catalyst and also for the removal of hardness. SiCl4 can be easily hydrolyzed by water while CCl4 cannot be hydrolyzed. Why? Is there any need to tell it again? SiCl4 has vacant d orbital, but CCl4 has no vacant d orbital or no d orbital. How are fullerenes prepared? It is an important question. Fullerenes prepared by heating graphite in the absence of air, in silent electric discharge, in an electric arc. In the absence of air, there should not be oxygen. If there is oxygen, carbon dioxide will form. So that is very important. In the absence of air. Here it is given us in the presence of inert gas like helium or argon. Distinguish between silicons and silicates. This is a repeated question, isn't it? Silicons are organosilicon polymers containing R2SiO as the repeating unit, while silicates are compounds of silicon in which SiO4 4 minus tetrahedra as basic structural unit. Okay, diborane is an electron division compound. Name the special bonds that present in diborane. It is the hydrogen bridge bond, that is a 3-center 2-electron bond. What are silicons? Write its general formula. A repeated question. Silicons are inorganic polymers. General formula R2SiO times. Can see it, the answer. Borax, orthoboric acid, and diborane are some useful compounds of boron. Write the chemical formula of borax, Na2B4O7. Boric acid is not a protic acid but acts as Lewis acid. Justify. Told it several times. Explain the structure of diborane using diagram. Repeated questions. Borax, when you write the structure, you write Na2B4O7, 10H2. Butter of crystallization also present along with it. Therefore, the molecular, if you are asked to write the molecular formula of borax, you have to write Na2B4O7, 10H2O. The other structure difficult to remember. You study this one, Na2B4O7, 10H2O. Some elements can exist in different crystalline forms and are called allotropes. What are the important allotropic forms of carbon? Graphite, diamond, fullerene. These are crystalline allotropes. And carbon black, coke, charcoal. All these are amorphous forms of carbon, allotropes of carbon. Which allotropic forms of carbon is used as dry lubricant machines? Graphite. You know it. B. When sodium borohydride, NaBH4, is treated with iodine, I2, two gaseous products are obtained. One is hydrogen and the other is highly toxic gas X. You may understand it now. NaBH4 is treated with the iodine and NaBH4. Then NaI will form, boron hydride will form, which is boron hydride, B2H6 diborane. So gas X is diborane. It catches fire upon exposure to air when a gas X is heated with ammonia for a long time. A compound Y of ring structure is obtained. When diborane is treated with ammonia, we will get inorganic benzene, that is boracene. So Y is boracene, B3N3H6. That is an important question. How will you prepare boracene from diborane? That is an important question. Study it well. Boracene, you can see it. B-O-R-A-Z-I-N-E, boracene. Two important compounds of carbon are carbon monoxide and carbon dioxide. Why carbon monoxide is called a poisonous gas? It will combine with the hemoglobin to form carboxyhemoglobin. How is CO2 responsible for global warming? Carbon dioxide is a greenhouse gas, so it causes greenhouse effect and increases temperature of the atmosphere. What are producer gas and water gas? CO plus N2, producer gas, water gas, CO plus N2. Mention their uses, fuels. It can be used as fuels. Okay, it is a common question in inorganic chemistry. Match the following. Three-step matching. Inorganic benzene, what is it? Boracene. You know, inorganic benzene is boracene and B3N3H6. Last like beads, borax bead test. Borax and its formula Na2B4O7 10H2. Or this formula Na2B4O5OH 4 times 8H2. Fullerene carbon, where is allotrope of carbon. So allotrope carbon. Zeolite, softening of hard water. It is an aluminum compound. You can see it. It is a completed table. You can clarify your doubts. Okay. How can you explain the highest stability of BCl3 as compared to TiCl3? Here the answer is inert pair effect. BCl3 3 will be the stable valency. As we move down the group, S electron pair will become inert. Therefore, in thallium, +1 oxidation state is more stable. No need to explain it in detail. You would simply tell due to inert pair effect, TiCl3 is unstable and TiCl is stable. That is enough. While aluminum can form the ion AlF6 3-, boron is unable to form BF6 3- ion. Explain. Due to absence of d orbital, state whether the compound BCl3 is acidic or basic. BCl3 is electron division. It is a Lewis acid, so acidic. Write the hybridization state of boron in BF3 and BH4 minus. In BF3 sp2 and BH4 minus sp3. Okay, we discussed several questions. You can see many questions are repeating, and therefore you study all the questions very well.